Okay, and we're going to do one more before we get into some more difficult problems of how to solve solutions. But we're going to do one more example of how to solve this type of equation when you're adding two different types of functions and whatnot. So first off, just like we had before, what we're going to do is we're going to look at this and say, okay, should we get a common denominator? How can we proceed in doing so? So we see cosine, sine, tangent. There's nothing we can factor out, which is not cool. But what we're going to do next is we're going to change everything to sine and cosine to try to solve this function. So change into sine and cosine. So we have cosine of x plus sine of x. Tangent is sine of x, and that's going to be cosine of x. That's going to equal 2. Now from here, what we're going to do is we see that we need a common denominator. So we're going to multiply top and bottom by cosine of x over cosine of x times cosine of x. This can turn into sine squared of x over cosine of x. That equals 2. From this point, we're going to now combine. So now we have cosine squared of x plus sine squared of x. Hey, that should give us a little happiness. That's a fundamental trig identity, my friends. So now we're going to use the fundamental trig identity. We're going to talk about this because this is actually equal to 1 over cosine of x, and that equals 2. Well, from here is we have to solve for cosine. So now we're going to multiply both top and bottom by, or cross multiply. And so we have is 1 over 2 equals cosine of x. That's cool. All right, so now we solve the trig function. So we solve the trig function. That's what we got. Bing! All right. And then if you go right here, if we're looking at the graph, so we can graph the trig function. So if we think about the cosine graph, all right, cosine graph like this, cosine starts at 0, then it goes to pi over 2, then it goes to pi, then 3 pi over 2, and then 2 pi. But we're not including 2 pi because if you recall, in our restricted domain, that's an open interval. So we graph this, we're going to go from 1 to negative 1. It's going to go down. It's going to go to negative 1, 0, then here, and I'm going to put an open circle because it can't equal 2 pi. All right, so from here, we can then see if we set this up to 1/2, at 1/2, it goes. So we can see there's going to be two solutions. One in the first quadrant, one in the fourth quadrant right here, because that is when cosine is positive. That totally makes sense. All right, so graphing it, check using that. And sometimes you can use a graphing calculator, but this one's pretty easy because it's just cosine. Now, the last thing we're going to do is we're going to solve using a trig inverse. So from here, we're going to solve our trig inverse by taking the inverse cosine of both sides. And when we have that, that's going to equal x. Okay, cool. So once we have this, now we're going to solve for the variable. Okay, and the variable is, well, what is cosine of 1/2? Well, this is, we're not going to use a calculator here because we leave it in the first quadrant and the fourth quadrant. We know cosine is 1 and 2 is the hypotenuse. Well, this is going to be radical 3. Well, what is our reference angle? This angle right here, my friends, all right, which is x, all right? So x appears to be, well, what's opposite of the square root of 3? That's pi over 3 or 60 degrees. We also have our other angle, which is going to be right over there, which is also, this is going to be, if you draw a little triangle, 1 and 2. So it's going to be negative square root of 3. Well, in any case, that's also going to be, all right, a pi over 3, so a multiple of 60. So it's going to be 300 degrees, which is actually going to equal, oh, what is that? 5 pi's over 3. And that's our other angle. So those are our two solutions to our function. Well, this was a pretty cool one, not too hard. It looked very complicated in the beginning. However, using the properties that we know, change sine and cosine, get a common denominator doing some algebra, simplifying, knowing that our trig identity right here, which equals 1, then we solve for cosine, using our trig inverse, graphed it out to verify we had two solutions. And then we find our two solutions to be pi over 3 and then 5 pi over 3. Okay. Well, hope that helps and explains this one. Another cool one. Another day, good day's work. Good luck and God bless in the rest of your problems.